Okay, hi kids. Now we'll be going with this paper discussion. Yeah. Okay. Looking at the first question. The first question goes like: two fixed positive charges of charge capital Q and another charge small q are placed as shown. One can easily see that Q is in equilibrium. Consider the given information and which of the following is correct. So you can see the distances are same, so you can see net force will be 0. Now suppose Q is positive. Now they are talking about suppose small q is positive. Now these two are positive charges anyway. If small q is positive, what will happen? This will be repelling and this will be pushing it this way, so the net force will become 0. Now if you push it slightly this way, what will happen? Then this repulsive force will become more and this repulsive force will become less, so it will try to go back. So you may see like it may be stable equilibrium, but it is only along this axis. But when I say about stable equilibrium, then you need to consider overall possibilities. You can see that when you disturb it this way, the force because of this charge will be in this direction, the force because of this charge will be in this direction, so it will be going to infinity, it won't be coming back. That is unstable equilibrium. Similarly, if this is negative charge, if you push it this way, it will try to come back. It will be in stable equilibrium along this axis. But if you push it this way, this attraction will become more, so it will go there, right? So yeah, so whether Q is positive or negative, it will be in unstable equilibrium. In fact, not only this case, you can prove it in general case, like electrostatic equilibrium is unstable equilibrium, right? Now coming to the next question, the question goes like: a disk is uniformly charged with surface charge density sigma, and a point charge Q is placed along the axis of the disk, and that angle is given in the figure. Find the force acting on the disk by point charge. Now, the first thing is, okay, so if I take some ring element, the electric field because of this charge will be like at this point it will be in this direction, at this point it will be in this direction. I didn't draw the remaining. Now if I want to find the force on this element, then what I need to do? I need to find the fields component. Now you can see like fields, other component will be getting cancelled. You can see this field will be having one this component and one radial component. That radial component will be getting cancelled when you take the whole ring. So only this horizontal component will be surviving by symmetry, you can say. Now I need to find electric fields component in this direction and multiply with the charge, right? Because the distance is same, so electric field magnitude is same, its component magnitude also will be same. So basically if I want to find the force on this element, what I need to do? I need to find electric field direction along the area, electric fields component along the area direction, and I need to multiply with the charge on the element, that is sigma ds. Now ds, if I take it inside, it will become ds bar. Now why I am doing this is the sigma is a constant, I can take it out of integration. So integral E bar dot ds bar. So I need to integrate E bar dot ds bar for this whole element. So it will turn out to be what is E bar dot ds bar? E bar dot ds bar is flux, right? So if I integrate, I need to get what is the total flux because of this charge in this circular region. And this result, I remember the result, so I am directly using that result. So that's the reason I did the question this way. Now the result comes from here. I think it must be there in the notes. So if someone wants to refer, they can text me over WhatsApp. I will be forwarding it, but it will be there in your notes most probably. Going to the next question, a charge Q is placed inside the conducting shell of radius R as shown. Yeah, I think so. This C is center, this B is this circumference, this A is this circumference, and it is grounded here. Now the important thing is when a conductor is grounded, its potential will be 0. The meaning is, and conductor's potential at every point will be same, right? So this potential A and this potential B will be same. But what they are asking potential at A due to charges on the shell. Now we need to find why charges on the shell will be coming into picture. We will see that. Now I am taking some Gaussian surface in the material of the conductor that is having some small thickness. Now in the Gaussian surface, now no matter which point I take, electric field is 0 because it is in the material of the conductor. If electric field is 0, then the flux through that element is 0, flux through this element is 0, total flux is 0. So total flux through this Gaussian surface is 0. The meaning is total charge enclosed must be 0 by Gauss law, right? So how can the total charge enclosed be 0 if there is already plus Q? So there must be minus Q, which must be induced on the inner surface, and that is non-uniform because it is not at the center. You have taken the positive charge here, so more negative charge will be induced here and less negative charge will be induced here, and you can see approximately the field lines also. Okay, now you can prove the outside charge will be 0, that you must have done in the notes anyway. So you can prove the outside charge is 0 by taking potential outside is 0, or the other way of saying it is potential due to these two is 0 outside as well as field due to these two will be outside. They will redistribute in such a way that field due to these two and potential due to these two will be 0 outside. Actually field due to these two is 0 outside. The meaning is potential here, 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 everywhere will be same, which is same as infinity, that is 0. So field due to these two is 0 outside. By that you can conclude potential due to these two also will be 0. Right. Now the important thing is this is non-uniform distribution. You don't know, I mean, yeah, we have to know the exact charge distribution to find some stuff, right? But the good thing about points is, even if it is non-uniform charge distribution, every charge is at equal distance r. So you can easily calculate the potential at C. But if you want to calculate at B or at A, it is not so easy, because you need to know what is the charge distribution, right? So if I want to find the potential at C because of the induced charges, that will be quite easy. It will be minus kq by r, because this charge is minus q. But if I want to find the total potential, it will be kq by this distance. This is potential due to this charge, and potential due to this inner surface is this much. So total potential at C will be this much. Now similarly, like if you want to get clarity, how to find the potential at A? Potential at A is 0, potential at A is 0, B is 0. Now potential at A because of this charge is how much? kq by this distance. Now potential due to this induced charge you don't know, I am calling it as VSA. So how we can find this potential due to this inner surface indirectly? I can say that VSA is, this total is 0, so VSA must be minus kq by RA, which RA distance, RB distance and RC are not given in the question, so you can't find this value exactly in the question. Now similarly VB also, potential due to this one is kq by RB, potential due to the induced charge at this point is this much, so the total is 0, so indirectly you can find what is the potential because of the inner induced charge. Next question goes like, a parallel plate capacitor separation D and is filled with 3 different dielectric materials having dielectric constant K1, K2, K3 are shown. Okay, take epsilon A by D is C. So then the equivalent capacitance. Now majorly it's like A or B. Now the thing is, yeah, I'll be explaining for this question because I have this PDF already. I mean, I don't want to draw the extra one. So okay. So there are 3 materials here and this is fourth material. So how you will be doing this question, or how you have to approach is, take small strips. Like this is plate, take one strip, other strip, so such strips. Now all this blue color represents K1 equal to 3, all this purple color represents K2, all this green color represents K3, and all this brown color represents some K4. Now the good thing is, all these 4 strips will look similar. These 4 strips will look, I mean there will be infinite strips, I have drawn only 4. So these 4 strips look similar. Now if you want to find the potential at this particular, now you can take any one strip and you can find what is the potential. Now the thing is, this potential difference is same at every strip. If you take this as 0 and this and V, so this potential here everywhere is 0, potential here everywhere is V. Now the thing is, so this potential is V, this potential is 0, so you need to find what is the potential here. Now this strip and this strip are same, so if you find potential here, the same will be here, the same will be here, the same will be here. That I can show you. When you calculate exactly, it will be 3V by 5, but I am calling it as X. So this potential I am calling it as Y, though you can calculate it as 6V by 8. This I am calling it as Z, though you can calculate it as 9V by 11. So the meaning is, all these potentials are same, which is equal to X, all these potentials are same, which is equal to Y, all these potentials are same, which is equal to Z. Now the important thing you need to understand is, this potential is not same as this, is not same as this. So you can't combine this. Now, okay, this potential is different from this potential is different from this. So how you can club them? You can club them like this, right? This potential is X, so you can club all this. This potential is Y, so you can club all this. This potential is Z, you can club all this. Now you can clearly see what to do, right? Now you can club all the X and you can take this as one pair, and this as one pair, and this as one pair, right? One pair, second pair, third pair. You can't do this because these plates are not at same potential. You can't draw like, you can't take this entire thing as one capacitor and this entire thing as other capacitor, because these potentials are not same. You can't combine them, right? So the next question goes like, what is the relation between small q and capital Q so that the potential is 0 at every point on the imaginary sphere. Now they said it is sphere, but you can see it is 2 dimension. The meaning is whatever figure, whatever charges are there, they are on this plane. They are on this plane, but this circle you can imagine like if you rotate it, you will be getting a sphere. You will be getting a sphere. Now the thing is, they are talking about sphere. They have given a circle, but what I can do from the question, I can take it for granted that for sphere the potential will become 0, for the circle the potential will become 0. But if I want to take the variables, what are the variables? This Q is variable. Now I need to know the distances also. Distance is not given, so I am taking this distance as x. So there are 2 unknowns, so I need only 2 points. So I will be taking this point and this point because they will be easy for me to calculate. They asked for sphere, we can see circle, but we will be looking at only these 2 points because we have only 2 unknowns, and those 2 points will give us the answer quickly if we know the result. Now potential here is 0. Potential here is 0. That is potential due to this one, which is kq by r by 2, and potential due to this one kq by x minus r. X minus r. This distance is x minus r. This equal to 0. Now similarly here it is kq by x plus r, x plus r, and k capital Q by r by 2 plus r, which is 3r by 2. Now these are the 2 equations. The 2 unknowns are q and x. So when you solve for them, you will be getting small q equal to minus 2 times of capital Q. Now similarly, if I want to calculate x, x will turn out to be 2r. X will turn out to be 2r. Now, yeah, the values were given in such a way that you can see that if this is r by 2, this is coming to be twice, magnitude wise. This is turning out to be twice again, right? So you can generalize the formula and you can even derive it. It's like, yeah, suppose if this is the question, if there is a charge q here at a distance r by n, what is the charge you need to place and at what distance you need to place so that the potential on this sphere will be 0. So this charge will be, if the distance is r by n, then this charge will be minus nq, and the distance must be n into r. This is easy to remember. Now why we are doing this is, suppose, yeah, we have seen one question earlier. So suppose if you keep a charge here, there will be inner induced charge. If this is a conductor and grounded, outside charge will be 0. Now I am not much bothered about that. I am bothered about only this charge and the inner induced charge. Now if you want to find the force because of this inner induced charge on this one, it is not so easy because it is unsymmetrical distribution. But what you can do is, you can try to recreate a question kind of stuff. So the potential, so you can remove this charge and put some charge outside, so you are not changing the conditions. So if the condition is the potential of this sphere has to be 0. The potential of this sphere has to be 0, which is our next question, right? Our next question is, if this charge is plus q, how much charge I need to place outside so that this sphere will have same potential? So both are equivalent questions. So what must be that charge? That charge must be minus nq times, right? So if you want to find the force between these 2 charges, what you can do? You can directly just find the force between these 2 charges. Both will be equal in magnitude. Going to the next question, find the current in wire AB. It is a resistance-less wire. So potential difference will be 0. Delta V equal to I into R. So R is 0, so delta V will be 0. So you can't get information about current from Ohm's law equation. So if you want to find the current in resistance-less wire, you need to rely on KCL. Now you can do it like this, maybe, whatever. So I will be assuming this as lower potential 0. This will be 10. 10, 10, 10. So this 0, 0, 0, 0. So this potential difference is 10, 10, 10. So I can find the current in this. Current will flow from higher to lower, 10, higher to lower, 10, higher to lower, 10. Now I can use KCL here. 10 is incoming, 10 is incoming. So 10 will be outgoing. Similarly, 10 is outgoing, 10 is outgoing. So 20 must be incoming. So if this is 20, this will be 20. Now this is 20, this is 10. So this will be 30. Now this is 10, this is 20. So this will be 30. So you have total current, you have total, battery also, you can find the equivalent resistance also, which is a common question. They will be in parallel, right? Given a setup of 0 deflection in galvanometer, potentiometer wire of length 1 meter and resistance 10 ohm. So find the value of EMF of this battery. So this is very basic question of working of potentiometer. So generally in potentiometer, what we will be having? We will be having 2 circuits, which we will be calling as primary circuit, and this is secondary. Now generally I'll be looking at the primary circuit first. Suppose if only primary circuit is there, 11 volt is there, 1 ohm is there, and this resistance is 10 ohm. So the total resistance is 11 ohm. So the current will be 1 ampere. So this is the primary thing we need to know. Now, in case of regular usage of potentiometer, what will happen? We will be moving the jockey in such a way that the potential there will be zero deflection. The meaning is there is no current flowing through this part. If there is no current flowing through this part, there won't be any current flowing through this part also. Or else I can say this circuit will behave like independently, as if like this is not there. So the meaning is whatever current we calculated, it will remain same, 1 ampere. Now, what is the good thing about current is not flowing here? This potential difference will be same as this potential difference. So let me say this potential is A, this is A. Now if this is B, this is also B because no current is flowing. Now if this is B, then this is also B because no current is flowing. So basically AB, this potential difference is AB, so this potential difference is also AB. Now you need to understand, you need to connect battery in such a way that this will be higher potential, this side will be higher potential. So this potential difference will be same as this potential difference. So now our aim is to find what is this potential difference. How we can find that potential difference? You know this length, so you can calculate what is this resistance and you can multiply with the current. So current into resistance, rho into L by A, that will give us this potential difference. Now you know something, for 1 meter the resistance is 10 ohm, so you can calculate what is the EMF of the battery. Basically this is the working of potentiometer. What we are trying to do, we are trying to find the EMF of the battery, but we don't know how to find the EMF of the battery. We know only how to measure the lengths. So we are trying to convert our aim of measuring EMF of the battery into measuring the length. Now similarly the next part will be like, after that you can even find the internal resistance of the battery by adding some external known resistance. That's up to you. In half deflection method, the resistance of resistance box in series with galvanometer is 10,000 ohm. When the galvanometer is shunted with 10 ohm resistance, its reading drops to half initial value the resistance of the galvanometer is. Now these are the two given structures or cases. So in the first case there is galvanometer and there is very high resistance connected in series. Let me say this current is I. In the next case you are connecting some 10 ohm in parallel, and now the current in the galvanometer is I by 2. Now if the current in the galvanometer is I by 2, now let me say the resistance of galvanometer is G. So what I can say, this potential difference will be same as this potential difference, which is I into G plus I into 10K. I into G plus I into 10K, where G is the resistance of galvanometer. Now similarly, if this current is I by 2, this potential will be I by 2 into G. So if this potential is I by 2 into G, this potential is also I by 2 into G. So this current will be I by 20 into G. So similarly, this current will be this current plus this current, I by 2 plus I by 20 into G. Now similarly, this potential difference, when you write loop equation, E will turn out to be this potential difference plus this potential difference, which is I by 2 into G plus this thing. Now I know two equations, I can compare them. And when I solve it, I will be getting approximately 10 minus substitute the values. Now without the values I am trying to do it because there is a name for the method, half deflection method. So the meaning is we can do it much easily in general, right? So this is general format where capital R is the resistance of this one high resistance, I am taking it as capital R, and the other shunted resistance I am taking it as small r. Now what I can do is I can cancel R. Thereafter I can see like generally galvanometer resistance will be very small when compared to that, because we are connecting very high resistance, right? So I can neglect this. I can neglect this when compared to this part. Now you can see approximately what will happen is, this R and this R will get cancelled. 1 plus G by R will turn out to be 2, or G by R will turn out to be approximately 1. So that is galvanometer resistance will be almost equal to the resistance what we are connecting in parallel. So what is this method? In this method we are trying to find what is the resistance of galvanometer. For that what we will do, we will connect some high resistance in series and we will see what is the deflection. Thereafter we will try to vary this resistance so that half current will be flowing through it, right? So then what we can conclude, we don't have to measure anything. We can say galvanometer resistance will be almost same as this resistance. Two small current carrying elements are placed as shown. So you need to find forces between them, small. So it is like, now you can see if I want to find the force on this one, what I need to do, I need to find the field because of this one here, field because of this one. Direction wise it will be in this direction. So magnetic field is in this direction. So L bar cross B bar, the force is in this direction. The force on this one is in this direction. Now similarly, if I want to find the force on this one, I need to find the magnetic field due to this one here. Magnetic field due to this one here is 0 along the line. So if the magnetic field is 0, then the force is 0. You can see force on this one is turning out to be this direction. Force on this one is 0. So I can clearly say they are not equal. They are not equal. So Newton's law of forces, Newton's third law of forces, like third law of in form of forces won't be valid. So be careful when you are taking about, in magnetism, be careful like if you are applying Newton's third law, and it was picked from here, right? That's from NCERT. In a thought experiment, at a given moment, two protons are parallel to each other, so considering electric and magnetic interactions. So anyway, you know, if two protons are going, like electrostatic force will be repulsive and magnetic force will be attractive, similar currents, right, similar direction. Now if you want to compare the magnitude, now what you need to do, how to find the electrostatic force, it is like you need to find the field and multiply with the charge, so which will turn out to be kq square by r square. Now if you want to find the magnetic force, then what you need to do, you need to find the magnetic field here. Magnetic field will be how much? Mu naught by 4 pi into q into v bar cross r bar by r cube. V bar cross r bar by r cube. Now here all are perpendicular, r bar and v bar cross r bar. Right, magnetic field will be in this direction. So if magnetic field is in this direction, then the force on this one will be L bar q into v bar cross b bar. So force will be attractive, that you know. So how much will be the magnitude of magnetic force? Q into v into b, right? So it will turn out to be this much. Now you could have done the other way also. The other way is, if you know what is electric field here, you can calculate the magnetic field easily. Right, I am just modifying the magnetic field equation and I am converting, like if you know electric field equation and what is the velocity of this charge, velocity of this charge, then you can find what is the magnetic force, right? Yes, a magnetic field you can find. Now after finding magnetic field, then you can use q into v bar cross b bar to find the magnetic force. Anyway, whatever you do it, then if you take the ratio, then it will turn out to be this much. Now you know mu naught epsilon naught is 1 by c square. So from there you can get the required answer, right? Okay, and the next question goes like, magnetic needle placed on horizontal table is initially pointing along the direction AB. So initially it is pointing along this direction AB. That is BH is along this direction. BH is along this direction. Now if I am standing here, magnetic field generally will be, magnetic field line will be somewhere along this direction. When I take its horizontal component, it will be this direction, vertical component will be in this direction. Now I am not bothered about vertical component because needle can't rotate. Whatever needle I will be taking can't rotate in this direction, it can rotate only in this plane. It can't rotate in this plane, whatever needle I am going to take now. Now in order to measure BH, what we are trying to do is, we are creating, now this is horizontal magnetic field, but we are creating some magnetic field whose value is 1 microtesla along this direction. So then what happened is, initially when I am holding magnetic needle, it was pointing in this direction because obviously magnetic field is in this direction. Now when I am creating something in this direction, then the net magnetic field will be somewhere in this direction, so magnetic needle will be pointing in that particular direction. Now what they said, it is pointing at an angle 45 degrees, The meaning is, resultant of this BH and this magnetic field created will be along 45 degrees, right? So this was the already existing magnetic field, this is the magnetic field created. Now the resultant will be pointing in this direction. So I can say resultant of this magnetic field and this magnetic field, will be making an angle 45 degrees. So you can take tan theta, from there you can get what is the horizontal magnetic field. Now this is the same principle we will use in many devices in that particular chapter. What we will be trying to do, like we will be having some known thing and we will try to find some unknown. Here known thing is the current what we are passing through galvanometer. So when you pass, it is like, so you can pass the current through this and you can create some magnetic field in this direction. So what you are trying to do here, you don't know BH, so what you are trying to do, you are trying to pass some known current so that you can create some known field, and you can take note of angle, because the easy things what we can measure are length, angle and time. So previously we have seen in potentiometer we are measuring length, now you can see we are measuring angle. Our aim is to find magnetic field horizontal component, we are converting that aim into measuring angle. Sometimes we will be knowing horizontal component, we can find current anyway. So yeah, maybe if you want you can see the example, you can try it. The next question was like when the switch is shifted from position A to B, so what will happen to the current? Now it may seem deceiving that initially flux is through this loop, thereafter flux is through this big loop, so initially area is only A, finally the area is 2A. You may tend to do by Faraday's law, but there is a problem with Faraday's law. He didn't give any reason. So we understood the reason. There are only two reasons why EMF will be getting generated. One is motional EMF, one is induced electric field. The meaning is motional EMF will happen when you move a conductor in a magnetic field. Induced electric field will happen when there is a time varying magnetic field. It is not time varying magnetic field, so induced electric field option is not there. Now you are moving this conductor but not in magnetic field. There is no way magnetic field can affect it. So there won't be any induced EMF, there won't be any current flowing through this. Okay, thus this is also the same example. Now going to the next part, a conducting strip is placed and it is moving the velocity and magnetic field B is applied. Okay, you can see dotted dots, so the meaning is magnetic field is in this direction. Dotted circle which is directed towards us, a galvanometer is connected. So what will the galvanometer be reading? What will be the current direction? What will be the current direction? Now again by Faraday's law, if you go like, you may feel that there is flux is not changing through this strip, but it has nothing to do with induced electric field because magnetic field is not time varying. Now let us see what will happen if you try to understand the motional EMF way. Now there is conductor moving in a magnetic field in this direction. So what will happen, like V bar cross B bar. So positive charges will try to accumulate this side and negative charges will try to accumulate this side. The meaning it will try to push the current this way. The meaning is electrons will be pushed this way or the current will be going this way, right? Again, Faraday's law may tend to deceive you here, but you need to know Faraday's law, you need to know what is the reason behind it. Now Faraday's law uniquely combines, maybe some people say magically combines, two unrelevant phenomena. One is motional EMF, one is induced electric field. So as it relates both of them, now if both of them are present at the same time, then instead of calculating motional EMF separately and induced electric field separately, you can directly use Faraday's law. That saves time in the questions. Now the next question was like, you need to find what is the impedance, and I represents complex number. So anyway, this is I think common question. So if the current is I, then if you take current as reference, then the voltage across the resistance will be in phase, across the inductor will be leading by 90 degrees, across the capacitance will be lagging by 90 degrees. Now if you find the resultant of these three, it looks like, okay, resultant of these two and resultant of these, this entire stuff will look like this, I into root of R square plus X minus X. But the resultant of all the voltages must give me source voltage, that is easy. So if you want to find root of R square plus XL minus XC, everyone must be knowing it. Now if you want to represent in complex form, complex number, so it will be the same as magnitude of this one. If this is a complex number, then the magnitude will be root of R square plus root of R square plus XL minus XC whole square, right? So the other way of doing it is, you know, if you are passing a current, voltage across the resistance will be in phase, but voltage across the inductor will be leading. So what I can do is, instead of inductor, I can replace with a resistor whose impedance, whose resistance is J into XL, where J represents complex number. Why we are taking J is, we will be using I for current. So J represents complex number. If some current I is flowing, then potential drop is I into R. Here I into XL but multiplied with a complex number, the meaning is it will be leading by 90 degrees. Now here it is multiplied with minus J, the meaning is it is lagging by 90 degrees. So you can try to convert this one to this one. Thereafter you can use all the rules of series and control of resistors. Now we are in series, so the equivalent resistance is R1 plus R2 plus R2, R1 plus R2 plus R3. So this is the equivalent resistance. So if you want to find impedance, that is the magnitude. Now similarly, The inverse of impedance is called as admittance, so you need to find what is the admittance. Again here complex number. Now what generally we will be doing, I'm calling the current in this one is IR, IL, IC. So I'll be taking this as reference. If I take this as reference, the voltage across this will be in same phase. If I take this as reference, then the voltage across the inductor will be leading. If I take IC as reference, then the voltage across the inductor will be lagging. But what is the common thing among all these three figures? It is their voltages are same. So the meaning is I need to draw the figure by taking reference as E. Reference as E. So when I draw the figure by taking reference as E, current in resistor will be in phase, current in inductor will be lagging the voltage by 90 degrees. Current in the capacitor will be leading the voltage by 90 degrees. Now when I try to combine all these figures, then I will be getting this. Now the resultant of all the currents, this and this resultant will be this much, so the total resultant is this much. Now that total resultant must be equal to the total current. Resultant current, that is this current, this plus this plus this current value you will be getting by vector addition of this, right? So thereafter you will be using corresponding. So this is the magnitude and phase you will be using, and you will be getting the instantaneous value also if you want. Now E by I is Z, so I by E is admittance. So I by E will be this much, which is magnitude of this complex number. Now how to get in complex format? As I said, you can replace resistance with R, you can replace inductance with resistance JXL, capacitance with inductance minus capacitance with resistance minus JXC. So now all these three are in parallel, so equivalent resistance will be 1 by R plus 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by Z will be, now you need to understand how this J from the denominator came into numerator. You will be multiplying and dividing with J, and J square is minus 1, right? Anyway, so that you can do. Now the next question goes like, a parallel plate capacitor is formed by two discs, the space between which is filled with homogeneous poorly conductive medium. The capacitor was charged and then disconnected from the power source. So ignoring the edge effects, magnetic field in the capacitor will be absent. The time varying electric field produces magnetic field. And in the question it goes like conducting medium conducts the current. So you have to assume that you have to understand that it conducts current. Now initially this okay, let me say at certain moment this plate has charge Q, this plate has minus Q. Now what will happen? Current will start flowing. Now if current is flowing, what will happen? This charge will reduce, right? Magnitude wise this charge will reduce. If this charge is reducing, the electric field inside will reduce. If the electric field inside will reduce, there will be displacement current, because wherever electric field changes, then magnetic field will be there, or you can try to understand it by displacement current. So how to find? Let me try to find the displacement current. So electric field inside will be given by sigma by epsilon naught. I'm taking the whole together so that the calculation will be easy. I can show you, like, even if I take a small element also, I can show you like in that region displacement current and conduction current will be same. Now I'm calling it as conduction current. Whatever current is happening because of charge flowing, that I'm calling it as conduction current. Whatever current, that imaginary current called displacement current, which is happening because of the change in electric field, I'm calling it as displacement current. Now electric field in this total region is uniform because we are neglecting edge effects. Now flux through any plane will be how much? Into area, that is Q by epsilon naught. Now rate of change of flux is 1 by epsilon. I'm worried about only the magnitude, so into dq by dt. What is dq by dt? Dq by dt is magnitude wise the leakage current, that is conduction current. Now what is, I'm taking this epsilon naught into d5 by dt, this is displacement current, right? So the important thing is conduction current is happening this way, but displacement current will be happening in the opposite way, right? It will be in the direction of increasing electric field, but electric field is decreasing this way, so displacement current will be in this direction. And magnitude wise, you can see conduction current and displacement current are equal, so net magnetic field, the net current will be 0 if you want to use Ampere's law, right? Now similarly you can do for any small area. I can take any small area and I can do the same thing. Flux through that small area will be this much. So rate of change of flux I can find, I can take this epsilon this side and I can find what is the charge density of displacement current and charge density of conduction current. So they are turning out to be equal. So no matter what element you will be taking, densities are same, so the current will be same. So magnetic field will be 0. Going to the next question. Two oppositely traveling electric field waves are given by these two. Now you can see this wave, this represents it is traveling along positive z direction. Now x axis, y axis, z axis, I cross j is k. Now electric wave is traveling along positive z. This wave is traveling along positive z and electric field is along I cap. So magnetic field will be along j cap. E bar cross b bar direction must give me velocity direction. So when a wave is going along this direction, whose electric field is this way, then the magnetic field will be in y cap, Now similarly for this one, this electric field, okay, this wave is traveling along negative z, and electric field is still in this direction. So the magnetic field will be E bar cross B bar, which is velocity direction. So B bar is in negative y cap, negative j cap, that is y. So if the electric field is this, then magnetic field will be its maximum thing into it will be in phase with the electric field. So same cos kz minus omega t, but what is the direction of propagation? J cap. The first one is j cap, right? Now second one is minus j cap we got, and magnitude b naught, and it will be in phase with E electric field. Now if you add these two magnetic fields, you could have added this one also. You can see like it will be forming standing wave of electric fields, it will be giving standing wave of magnetic field. When you add these two, you will be getting this one, and you know what is the relation between E naught and B naught, E equal to CB, right? So you can put it there and you will be getting the required answer. Consider a case when the object is viewed through simple microscope. So magnification will be equal to magnifying power always, or it will be never equal, or we cannot compare because the dimensions are not same. See, they don't have dimensions, so option 3 is wrong. They are the ratio, so they won't be having any dimensions. Now this question is from NCERT, and take the focal length as 10 centimeter. Here it is not 9, 10 centimeter. Now the question goes like, in this particular question, when the object is at a distance 9 centimeter, then what is the magnification produced by the lens and what is the angular magnification, and is magnification equal to angular magnification or not? Now what is the whole purpose is, like if there is an object, if you want to see it clearly, you need to bring it closer, because the more far it is, the less will be the angle subtended, so we won't see it clearly. So if you want to see it clearly, you need to bring it closer so that the angle subtended will be more. But there is a problem, we can't bring it below 25 centimeter generally, right, for normal human being. So for normal human being, what is the maximum angle what can be the maximum angle of the object that can be subtended when you place it at a distance 25? So maximum angle subtended in normal cases, if you bring the object till a distance of 25 centimeter, this d generally called as 25 centimeter. So when you bring the object to a distance of 25 centimeter, let me say height of the object is HO, then theta naught is the angle subtended with your eyes. So this is the maximum angle that can be subtended in normal case. Now if the angle is small, then you can approximate it to tan theta equal to theta, and which is h naught by d. But what we need now, our purpose is to increase the angle subtended by keeping the image, or by keeping whatever we are looking at it more than 25 centimeter, right? So what we will be doing here is, we will keep a lens. Now if lens is not there, we can keep the object only at 25 centimeter. Now when we keep the lens, we can move the object even closer. Now let me say the object is of this much height. If the object is here, then the angle subtended would have been less. So what we are trying to do, we are trying to move the object forward so that the angle subtended is increasing. If it is here, then the angle subtended is less. If it is here, then the angle subtended is more. So we are trying to increase the angle subtended, but our eyes won't be feeling this. Our eyes will be feeling this, right? So we will feel like the rays are coming from here. So this is what we are going to do. For that, what we are doing, we are keeping the object at 9 centimeter, which can't be practically feasible if lens was not there, because we need to keep it more than 25 centimeter, and we are using focal length 10 centimeter. Now if this is the object, image will be formed at a distance 90 that you can get by lens formula. Now magnification will turn out to be, you can find that also, magnitude wise it will be V by U, which is 10. Magnification is 10. The meaning is this image height will be 10 times more than this. Now what about angular magnification? That was the angle which can be subtended initially. without any instrument. Now what is the angle subtended with instrument? It is tan alpha will be almost equal to alpha, which is h0 by 9 or hi by 90. Now out of these two we can use any one of them, but generally I will be using this because you can see h0, it will be getting cancelled. Now when I take what is the new angle by old angle, new angle with instrument by old angle without instrument, this is called as angular magnification, which will be h0 by 9 by h0 by d, which is 25. So it will turn out to be 25 by 9, which is 2.8, and you can see angular magnification is 2.8. Angles won't be having dimensions in the first place, and if you take ratio, nothing will be having dimensions, right? So on magnification, length by length, it won't be having any dimensions again. So they won't be having dimensions, but magnitude wise also they are not equal in this particular case. But if you look at next question, where they says like, at what distance should the lens be placed in? Figure in exercise 9.29, but it is not 9.29, it's the same question, it is like 9.23. With maximum possible magnifying power, Now the thing is, you will understand when it will be maximum possible magnifying power if you do it without numbers, but you take it for granted that when the image is forming at 25 centimeter, it will be maximum magnifying power. Now I am trying to find at what distance I need to keep the object so that image will be formed at 25 centimeter, and if the image is formed at 25 centimeter, then that is the case of maximum magnifying power. Now I will be following the same thing. I know the image distance, so using image distance and lens formula, I will be finding what is the object distance. That will turn out to be 50 by 7. Now object distance is this much, then the magnification will be v by u magnitude wise, that I can get it as 7 by 2. Now without lens the maximum angle subtended is this much. Now with lens the maximum angle subtended is, in this particular case it is h0 by 50 by 7 or hi by 25. I will be using this one because h0 will get cancelled. When I do that, I will be getting 7 by 2. So in this particular case they are equal. Now if you do with values, you won't be finding like, in which case it will be equal, in which case it not be equal. But if you do the derivation without values, then you will understand that it will be equal only in this particular case when the image is forming at a distance 25, right? So in YDSE, if a monochromatic source is replaced by source of white light, this question I just picked from NCERT, that you can have a look, right? You must be knowing. In YDSE, if d equal to 5.2 lambda, then maximum number of bright fringes. Now it is 5.2 lambda. So if I go with figure, suppose this distance is 5.2 lambda. Now here the path difference is 0. Now when I go somewhere, the path difference will increase, lambda it will become 2 lambda it will become. So what is the maximum path difference I can get when I go to infinity? When I go to infinity, then it feels like almost all the 3 points, S1, S2 and this point, all are on the same line. When I go far away, the distances will feel as if they are on the same line. That is, the path difference will turn out to be S2p minus S1p. So when I go very far away, the path difference between these two will turn out to be simply this distance, which is S2p minus S1p, which is this distance. So the maximum path difference is 5.2 lambda, which happens at infinity. Similarly, here also it happens at infinity. So 0 is there, lambda is there, so 5 lambda. So 0, lambda, 2 lambda, 3 lambda, 4 lambda, 5 lambda. Similarly, down also 1 lambda, 2 lambda, 3 lambda, 4 lambda, 5 lambda. So totally it is 11. But the thing is, it won't be of equal fringe width, because in YDSE, okay, this is the derivation of YDSE, what I will be doing. So we'll be taking some random point, and this distance is small d by 2, and this distance is y, this is capital D. Now I will be finding S1p and S2p, and I will be subtracting S2p minus S1p. So that you can see. Now if I want to find S2p, what I need to do, I need to make a triangle like this, where this length is y plus d by 2 and this length is capital D. So this length will be root of this square plus this square, root of d square plus y plus d by 2 whole square. Similarly, S1p will turn out to be this much. Now I didn't take any consideration right now. It's just like Pythagoras, no approximation. Now I am taking some approximation, which is small d is much less than capital D. The meaning is this distance is very big when compared to this distance. Now in that case what I can do, I can see like d square by 4 is very small when compared to the other things, right? So I can neglect this term, so it will turn out with this, it will turn out with this. Now I am taking root of d square plus y square common, and I am using the binomial approximation because this small d is coming into picture, right, which is very small. So I can say this is much less than 1. So when I do the binomial approximation and when I do this stuff, I will be getting something like this. Now this I can see it like d into something. This is y by root of y square plus d square. So y by this dotted line is root of y square plus d square. So I can say it as sin theta. Sin theta is y by this. So I can say it as sin theta. Sorry, this has to be sin theta. This has to be sin theta. So I can write it as d sin theta. Now you can see how you got d sin theta by dropping a perpendicular. Generally you will be dropping a perpendicular and you will be saying this extra distance is d sin theta, where the theta is the angle subtended here, right? Okay, so d sin theta, sorry, this has to be d sin theta. Now if y is much less than d, now I am going with one more approximation. Y is much less than d. The meaning is I am observing the fringes only in this surrounding region, which is very small distance when compared to this one. Now when I do that, then tan theta, then angle will turn out to be small, right? That you can see from the figure, or you can see from here itself. When y is much less than d, then this will turn out to be y by d, which is tan theta. Right? So what are the approximations in which we will be working on YDSE? We will be working on the approximations. This distance is much smaller than this distance, as well as we are looking in the surroundings. Only when we are looking in the surroundings, we can say that fringe width will be almost constant. But when you are not looking in the surroundings, fringe width won't be constant. That you can see. Generally, path difference will turn out to be d sin theta. Without the approximation of the surroundings. Till now, when you are getting d sin theta, we have done only one approximation, that is small d is much less than capital D. We are not looking at the surroundings of the central bright fringe right now. So this will turn out to be this much. Now you can see y is not proportional to path difference. Proportional to path difference. If y is proportional to path difference, then what we use it to get? We use it to get y1 where first bright fringe is formed, y2 where second bright fringe is formed, y3 where third is formed, and what we will be doing, we will be checking what is y2 minus y3, the distance between first and second and third and second, and that used to turn out to be same. But in this case what will happen? If it is proportional, if this term was not there, then y is proportional to delta. So y2 minus y1 will turn out to be 2 lambda minus 1 lambda. y3 minus y2 will turn out to be 3 lambda minus 2 lambda, where the fringe width is same. But in this particular case, where we are not looking in the surroundings of central bright fringe, it is not proportional to path difference. So it won't turn out to be the equal fringe width. That you can see in many ways, whatever it is. Now the next question goes like, the polarizing angle is 60 degrees. So in polarizing angle, what will happen? When you send it 60 degrees, reflected ray will be making angle 60. But under this Brewster condition, reflected ray and refracted ray must be making 90 degrees. So the remaining angle, this is a straight line, so 60, 90 went. So remaining will be how much? 180 minus 90 minus 60. That you will be getting 30, right? So 60, 30, 90, 90 plus 90, 180. Similarly, the next question, 25% is alpha decay and remaining is beta decay. So that you can do it like dn by dt equal to minus lambda 1, this is alpha, minus lambda 2 into n, and they have the ratio. Now lambda 1 by lambda 2 is log to t1, log 2 by t1, log 2 by t2, right? So you can do it. Now the next question, fourth order bright fringe is coinciding with sixth order of lambda 2. That is, so central will be forming at the same point. So first, second, third, fourth is coinciding with the sixth of the second one. That is 4 fringe widths equal to 6 fringe widths of the second one. 4 fringe widths of the first one equal to 6 fringe widths of the second one. From there you can calculate lambda 2, you will be getting the required answer. So the next question goes like, you are sending a ray perpendicularly. When you send a ray perpendicularly, what will happen? It will go as it is. Now you need to find what is this angle. So this is A, this is 90. So this will be 90 minus A by looking at this triangle. If this is 90 minus A, if you drop a perpendicular, this angle will turn out to be A. So you can apply Snell's law. So which will be n sin A equal to 1 sin 45. Now apart from that, they have given how to find the refractive index from the question, that is speed is given. So you can find the refractiveness and you can get everything. And okay, those who didn't mark 5 questions, they must have like looked into this question, because you need to find sin A, so whose value lies between 0 to 1 according to rounding off, either it has to be 0 or 1. So you could have guessed it. You could have taken 50-50 chance if you don't know how to do it. Okay, an optical system consists of something. So what you need to do, you need to place a plate so that image will be formed at 35 centimeter. So this is the lens. If the rays are if focal length of the lens will turn out to be 31.25. So if you are sending parallel rays, they will be converging at a distance 31.25, but you need to converge it at a distance more than 31.25. The meaning is you need to keep a slab so that it will shift it by a distance 35 minus this thing. So shift due to slab must be how much? 35 minus 31.25. That you can get the required answer. Now the next question goes like, suppose 2 electrons are revolving around proton. So what is the total energy? So generally this is the Bohr's law derivation, right? So when there is nucleus, the force of attraction between nucleus and the electron, that will be providing the required centripetal force, and mv equal to h by 2 pi. Now when you solve these two equations, now from here I have written mv square by r, and I will be dividing these two. I will be getting velocity, I will be substituting it back, and I will be getting the radius. After that I will be finding the kinetic energy, I will be finding the potential energy, I will be adding the total, then I will be getting the total energy. This is how you do Bohr's derivation. Now we will be following the same thing. Now the force on this one will be because of this plus this, that is attraction force between these two and repulsive force between these two, that will be providing the net centripetal force. This is the attractive force between nucleus or this proton and this electron, and this is the repulsive force between these two, equal to mv square by r. So from there I will be getting one equation, simple. Total angular momentum. This angular momentum is mvr, this angular momentum is mvr. So mvr. Now again I am doing the same. From here I will be finding mv square r and mvr. So I will be getting velocity, I will be substituting it back, I will be getting the radius. Thereafter kinetic energy is for only these two electrons, so I will be finding kinetic energy 2 times of half mv square, and I will be finding potential energy will be between these two and between these two. So this first term consists, this is into 2, the meaning is it is potential energy between proton and electron, and it is twice because there are 2 pairs, right? This for this, so it is 1. Now there will be potential energy between these two also, which will be this much, kq square by 2r. Now the total is this much. When I substitute those values, I will be getting something like this. When I add this total energy, it will turn out to be this much. Now they said this value magnitude wise it is 13.6. So you need to find what is this value magnitude wise, right? So you can get it. Okay, similarly the next question, you can read the question, and I think the solution is sufficient enough. So stopping potential is needed only 1.3, but stopping potential you are providing is, you are applying potential 10, so there won't be any photo current. So the next question goes like, a nucleus of 224 initially at rest emits alpha particle. The total energy given is 8, out of that 2 is emitted later as photon. 2 is emitted as photon later. So out of it 2 is gone as photon. The meaning is these particles are, this daughter nuclei alpha particle are going to take the rest of the energy, that is 6. So that is this kinetic energy. Now initial momentum is 0, so after reaction, if this momentum is p, then this momentum also will be p. Because of momentum conservation, I can say net momentum has to remain 0. The meaning is if this momentum is p, this momentum also has to be p. Now this kinetic energy will be p square by 2 times. Okay, this will be p square by 2 times of m. Now I am taking this mass is 4m, this mass is 220 m. P square by 2 times of 220 m equal to p square by 2 times of 4m. Total kinetic energy is 6. Out of it, 2 is gone as photon, so remaining leftover is 6, which will be a kinetic energy of this 2. Right. So now what I need to find? I need to find what is this value. So I can modify it. I can get p square by 2 times of 4m is 6 into 220 by 224, which will be almost 6. The meaning is almost of the total total energy utilized for kinetic energy, most of the energy is taken by alpha particle. It makes sense because the less mass it is, the more kinetic energy it will be taking, right? A positive charge particles, okay, I think this is a common question. So you will be sending something and you are sending at an angle 60, it is leaving at an angle 37. So you will be drawing the approximate figure, and you are sending at an angle 30, at an angle 60 with the vertical. So this total angle is 60. So it is leaving at an angle 37. So this width is given, which is r cos 37 minus r cos 60. R cos 37 minus r cos 60. So from here we will be getting the r value. Now the next question goes like, you are trying to construct compound microscope given two lenses f1, f2. How far apart you should place them so that you will be getting angular magnification 60 and normal adjustment. Normal adjustment means final image is forming at infinity. So for better resolution, you need to place small focal length as objective and higher focal length as eyepiece. So the same figure I will be drawing it here. Smaller focal length objective, higher focal length eyepiece. Now this is what will happen when lens is not there. If I am bringing a object, the maximum angle that can be subtended is height of the object by 25. Now I will be using it to find the angular magnification. Now let me keep it there. Now I will be coming into the question. The question is, finally, now you are keeping object somewhere. This object will form image somewhere. Now this will act as object for this lens, and this image is forming at infinity. So this object will form this image, and this image will act as object for this one, and image will be forming here. Now I need to draw at least two rays to get the image, but this is approximate figure when I know like what is happening. So this is the final angle subtended at your eye, and this was the angle without any instrument. So you need to take the ratio of these two. This is our aim. So in order to find beta, I need to get some other stuff like either H1 I need to find. H1 I need to find. Now in order to find H1, I need to do some other stuff. Now image is forming at infinity. The meaning is object must be at a distance of focal length, that is 4 centimeter. This value I got. Now what they said, they gave some information between this and this. They said that is 60 degrees. Angular magnification is 60 degrees. That is new angle subtended by old angle subtended without any lens. Beta by theta naught is 60. So beta equal to 60 times of theta naught. Theta naught is height of the object by 25 centimeter. Now what is beta? Beta from the figure you can see it as h1 by 4. Beta from the figure is h1 by 4. So from here what you can get, h1 by h naught is 48 by 5, or h1 by h naught. What is h1 by h naught? You can see it is excuse me. You can see it is the magnification produced by this lens, right? Magnitude wise, h1 by h naught. So I can say h1 by h naught is nothing but magnitude producer, or magnification producer, or I can say like it is magnitude is equal to y by x. I mean v by u, image distance by object distance. If I am calling this as x and this as y, so I can say h1 by h naught is nothing but the ratio of these two distances. So till here I got, but there are two variables, but there is some other thing I need to do to get one more equation. Now that is lens equation. Now if this is x and this is y, I can combine them using lens equation. Now I am substituting with values. Object distance is negative, image distance is positive with sign. So when I do it, I can use this relation here, and I will be getting what is the value of x, what is the value of y. Now I know what is the value of x, what is the value of y, but what I need to use, I need to find what is the length between them. That is, I need to find y plus 4, which is 10.6 plus 4, which is 14.6, right? So anyway, I can see like most people are not watching the discussion video, so I don't bother much about that. If someone wants PDF, you can text me. I don't want to take much trouble. Earlier I used to take in black and white, but okay, thank you.